you predict basically that HVAC equipment capacity will grow by 3.5 times by 2050.
I always say that adding more cooling does not necessarily mean that we increase the amount of energy that we consume in the region if we are smart about energy efficiency and selection of equipment and technology. Energy efficient, basically you depend on the weakest link in the chain from all the way to.
Yeah.
So if they don't continuously maintain their equipment, you could see up to 40% drop in energy efficiency and capacity.
What are the areas where we dramatically have to up our game, so to speak?
Yeah, as I mentioned earlier, this is one of the weakest link. I believe that one of the reasons that it's weak has to do with.
It's pretty hard, I guess. What kind of impact does that have on the entire sustainability agenda? Because it is massive.
That's a great point, actually.
Welcome, Nabil. It is a pleasure to have you on the podcast today.
Thank you for having me. It's my pleasure.
Today, I have an opportunity to talk a little bit more with somebody about regulatory matters, policy, standards in the HVAC space. I think that is always very interesting because it is a very old industry, but it hasn't really changed a lot in terms of the basic core principles of HVAC, how it runs. But you in the AHRI organization obviously are looking at the daunting challenge that we all have, increasing cooling capacity and energy use. So how can we make things more efficient? In one of the recent data that you published, you predict basically that HVAC equipment capacity will grow by 3.5 times by 2050. How does that sort of gel with sustainability? I mean,
yeah, actually, I was quoting the International Energy Agency. This is a report that they put together and said that the Middle East by 2050 will will have more than 3 times the current capacity in terms of equipment.
Yeah,
and I always say that adding more cooling does not necessarily mean that we increase the amount of energy that we consume in the region if we are smart about energy efficiency and selection of equipment and technology.
So what are then the drivers to be smart in that? Because I mean, being smart can be putting certain smart controls in there, use of AI, but the core principle is still the unit itself, the equipment itself.
Yeah, correct. I mean, to stay energy efficient, basically you depend on the weakest link in the chain from selection all the way to maintenance.
Yeah.
So all these elements have to be carefully studied and implemented, starting from equipment selection to handover to maintenance and service.
Yeah.
And also training technicians. If we don't have all these elements proper, then energy efficiency will suffer, especially in an area where people ignore a lot, which is maintenance.
We'll dig into that maintenance component in a little bit, because I think you're absolutely right. And obviously when equipment is being selected, you're still very much in the building process of a structure of a building. And the cost is actually, the majority of the cost sits in the whole operating phase of a building as such, and thus maintenance.
Yeah, correct. And just to go back on the point that you mentioned about how can we be smart about selection or equipment. I mean, the technology is there today, high efficient product, but we also need standards and certification. So standards and certifications set the floor, and innovation and technology raises the ceiling.
Yeah.
And to be sustainable, the market needs both. So in another International Energy Agency report, they looked at the region in terms of equipment that are sold in the market and their energy efficiency. And they found out from the study that a lot of the products that are sold are mostly entry level in terms of energy efficiency and close to the minimum energy performance standard that the governments have established. versus the ceiling of energy efficiency of the product that's available in the market is much higher. So they're staying close to the minimum.
Yeah.
Versus if you look at, for example, the US, Europe, and Japan, the average energy efficiency of an equipment is almost in the middle.
Okay.
That's because I think it's of awareness and willingness to spend additional capital in the front to save on the long term.
Yeah. And do you feel that in the region over here, that concept of moving much more to the middle is gaining ground, or is it something that is too much of a money-driven decision-making process?
Unfortunately, I mean, it's not moving as much as I would like it to. And to move the needle there, you have to do two things. One, the government has to continuously push this. So every few years, we see the government raise the minimum energy performance standards. But also you have some responsible corporations that are starting to be more environmentally conscious because of the net zero targets that we have coming, and because the government's here also starting monitoring carbon footprints of building. And there's reporting on that started this May, actually, of 2026.
Yeah.
So they're starting to be more conscious and doing more calculation to understand, the ramifications of selecting versus a certain technology or equipment versus others.
Yeah, and I guess that also ties back into, and you were part of those discussions in the COP28 discussion. I mean, the target set, reducing the energy or improving the energy efficiency by 50%, that is a massive goal if you think about that. How do we get there? Or is that just nice on paper?
You're correct. I mean, the target was to improve energy efficiency of equipment by 50% by 2030 compared to 2021 levels.
Yeah.
And also make, introduce other elements that would help energy efficiency, not just equipment efficiency.
Yeah.
So the government was supposed to start raising, the MEPS, we call it, or minimum energy performance standards. We have seen one jump, but it's not quite close to 50%. So we need we can't just rely on the government itself. We have to, make more awareness to end users, developers, conscious, corporations that want to really help in terms of environment and reaching net zero targets, to start using more energy efficient product. And also change the way we do things. I mentioned earlier that the importance of standards and certification. Standards create consistency of how we measure equipment and test them. And certification creates confidence, because a lot of times what we have in the market is equipment that they don't meet their catalog data. So I call it tolerancing. There's a lot of tolerancing. So when we have a standard that establishes MEPS, that's a great step number one. But to follow up with that, we have to have surveillance. And certification is one way to do surveillance. So we have to grab random units from the market and ensure that the product that I have is high quality and good energy efficiency, because that product is making it through the market somehow and ending up in buildings. And it's not helping energy efficiency.
And is that certification like a global standard that you're really after in this context, or is it something that needs to be done at the country level or more at an industry level? What would be the best way?
Yeah, great question. It can be both. For example, AHRI, which is a not-for-profit organization in the US, we were told by the Department of Energy to regulate for the industry to regulate itself. So they created AHRI back in the 70s and established standards. So it became also a standards and certification organization. So the organization basically established the standard and also does the surveillance on behalf of the government. So it also has to be adopted by the government. So we're working currently, for example, with Saudi Arabia. They have adopted similar concepts for commercial units. like chillers and other things. But it needs to be implemented on the wider scale of also small equipment.
Yeah.
Because small equipment are sold in very high volume, and it has, if not the same impact, more impact on the power consumption in the country.
Yeah, it's not really regulated in a central fashion, right? In a big building where you have a BMS,
yes,
you can obviously do certain things in the scheduling and whatnot. And even that is not always done efficiently, I guess.
Right.
But in a villa, you get a perfect duck curve at a certain point, right? When everybody comes home and starts firing up their AC systems,
Right,
etc.
right.
So how do you go about those things from an industry perspective? Is that actually something you can regulate or not?
I'll give you a quick example of, we tried, for example, in the UAE to regulate the set point of thermostats.
Yeah.
So they told the manufacturers you cannot have a thermostat where the temperature can drop below, say, 22 or 21.
Yeah.
Because we've done a survey once and we found out that the new generation, they like to set their thermostats at the lowest temperature, maybe 18 Celsius.
Yeah.
And when we questioned some of them, they said, that makes them feel luxurious so they can cover with a thick blanket like the Europeans or the Westerners. Yeah. And it gives them a luxury feeling, which is, to me, it's defeating the purpose of, saving. It's like having a coat and sitting in an air-conditioned, take the coat and you can raise the temperature and save energy, right? So the manufacturing companies continuously try to do education, but it has to be done on all levels.
Yeah.
Government, corporations, building owners. So education is key.
But the building owners obviously, it starts with the developers who start putting the buildings together, and obviously today's equipment may be more efficient than, say, 10 years ago because of some development that has taken place, change in standards and all those things. What I find always striking when I look in the market here is that question later on in the whole life cycle, is like who gains actually from that efficiency gain that is there in terms of hard dirhams in the case of the UAE or not. So how does a standard or guideline actually influence that in the long run? Is that something you can influence?
Before I talk about the standard, you raise a good point, is whose pocket is this going to hit? So if I have a more efficient equipment, I'm going to save more money on my annual consumption of electric power. In terms of standards and regulations, I mean, the main thing that we can do is to ensure that we provide high quality equipment that meets the minimum requirements and also the claims of the manufacturer. So if you are a professional engineer that's selecting and designing a unit, so you're getting what you have been told or have specified. So there are no surprises.
Yeah.
And for the developer, I mean, we also sometimes encourage doing some performance testing, because we are in a high ambient region. Units have to withstand, for example, high temperatures. So we do some operational testing on like 52 degrees Celsius. The unit has to run for a certain amount of time without being, with no tripping, basically, or
no breaking down.
Yeah.
Do you feel that everybody is aware enough of this particular thing when they start the process? Because I don't know if this is a myth or this is a reality, but the myth that I understand here is that HVAC systems by default are sort of oversized in buildings here for what they really should be. And yes, the ambient temperature is challenging, and the climate that we have to manage is very challenging, of course. But is that a myth that there is an oversizing happening by default, or is it?
Yeah, you're correct. Two things. One, unfortunately, when we talk about HVAC and HVAC, terminology, it sounds sometimes like Greek to people.
Yeah.
So when we talk about energy efficiency, we talk about SEER and COP, which is not easily understood by, non-technical people or people outside the HVAC industry.
Yeah.
So we need to try to simplify. So, for example, we've asked a lot of people, do you know what kind of system is installed in your building, for example, today? What type of system? They have no clue. All they know is they can reach a thermostat and raise or lower the temperature.
Yeah.
And so there need to be more awareness of, my selection and not just leave that selection to the installer or the contractor that's coming to service you or replace your unit, or if you have a new house, they're trying to sell you a unit.
Yeah.
You're totally relying on their selections and knowledge. You need to do your own homework. Yeah. In terms of oversizing, that's a big issue in the region because a lot of consultants, unfortunately, they want to stick to be on the safe side, like because we mentioned there are tolerancing in the market. So they're compensating for that by oversizing. And when you actually oversize, it's going to backfire in terms of energy consumptions because the unit is going to be much bigger than what you need for the space.
Yeah.
So it's going to continuously go on and off. So there's going to be on, off, which affects humidity. It affects the life cycle of the equipment. And it's going to cost more and be less efficient.
Yeah. Another big discussion, obviously, in the region is, and by the way, this is not necessarily a negative discussion, is the use of district cooling versus refrigerants or your own chiller plant, for that matter. What is sort of the trend that you see here in the region? Because we are front runners in district cooling globally, in the technology that is being used and how it's implemented. Is it a better solution than working with refrigerants, or is it actually another type of choice that you have to make?
District cooling is good in terms of the economy of scales because it's a large plant that can be run professionally and maintained also professionally.
Yeah.
In terms of efficiency, right now there are claims that it's the most efficient in terms of cooling buildings. If you use simple terms of some people may say it's 0.7 kW per ton, kilowatt per ton, or 0.65 kW per ton, versus conventional equipment, for example, like a wall mount unit. That's more like a 1.4 kW per ton.
Yeah.
But that's a claim that needs to be verified. Currently, we have standards that measure chillers as a standalone equipment. So today we are working with, for example, Empower and AHRI to develop a standard that doesn't exist that measures the efficiency of a whole district cooling plant.
Yeah,
it's going to be AHRI 245. It's under development as we speak.
Yeah,
and this will tell us if these figures I mentioned are correct. But in terms of building construction, a lot of the developers, they like using district cooling because they can save on equipment. All they have to do is put only an air handling unit, an FCU instead of putting the entire indoor-outdoor units.
Yeah.
And it can make sense in the areas where you have dense population or high rises.
Yeah.
Today, I think Dubai, like you said, or the UAE is one of the leading countries in the world. They have 25 to 30% penetration, and they're planning to reach 40 to 45% by 2030.
Yeah.
And basically become more like a utility company.
Yeah.
So just like you get electricity and water to your house or building, you're going to get chilled water, 6-degree water coming to your building as a utility.
It will put, no doubt, more pressure on the maintenance component in the operations then, because as coils get dirty over time, they obviously become less efficient also in heat transfer, and that has a profound impact on your delta T at the end of the day. Do you feel that it is still for say smaller communities or communities with villas, for example, that to go the refrigerant route, or is it something that is then also still qualifying properly for district cooling, or is it?
I think
equal?
in this region, we have like zoning. This is
Yeah.
a district cooling zone or not non-district cooling zone.
Yeah.
So if you have the example that you mentioned, if you don't have district cooling service, you have to go with a conventional way, with using conventional equipment.
Yeah.
But also just stressing on the point that you made about it's going to using district cooling is going to also, we have to be cognizant of all the other elements that is involved in like pumps, heat exchangers. Those have to be also be under the spotlight because they affect energy efficiency, heat transfer. Also inside the building, outside the district cooling control, you have the building owners. So if they don't continuously maintain their equipment, especially the fan coil units. In this region, we accumulate a lot of fine sand, dust, and also the filters that we use are not the best filters. They're not HEPA filters. They're just aluminum filters. So there's a lot of debris that's going to hit the indoor unit. So if those indoor coils are not cleaned continuously and maintained, you could see up to 40% drop in energy efficiency and capacity.
Green Minds is where industry leaders and innovators talk about what's next in sustainability. Sorry to interrupt the show, but if you want to know more about sustainability, make sure you hit subscribe. What kind of impact does that have on the entire sustainability agenda? Because it is massive. And if we all do not, let me rephrase that. If we all only focus on the monetary element, the cost of the maintenance or whose pocket is going to benefit, are we ever going to meet the COP28 targets that we have set?
No, it will be very difficult. So yeah, you're correct.
It's pretty hard, I guess.
Yeah.
Your organization is working a lot with manufacturers also, and not only from a standards perspective, but also looking at innovation and obviously improvement. How do you do that in an industry that is actually for the past 120 years sort of like built on the same principles?
Yeah, I mean, you're correct. The refrigeration cycle has been the same since it was invented over 100 years ago. But we have now new elements that helps improve energy efficiency, including controls, AI, and also creating hybrid systems. So, for example, we are to be more sustainable. I always say that professional engineers or MEP should get outside of their comfort zone and be more creative and think about technologies like geothermal, radiant cooling, thermal storage. Adding hybrid systems can always improve energy efficiency and elevate you to the next level that we need to reach our targets in this region.
What is sort of pardon the pun, basically the coolest innovation that you have come across recently in this industry that you were quite impressed with?
We don't have per se new innovations, but new applications that are becoming more trendy. One of them is radiant cooling, which basically can drop energy consumptions by anywhere from 20 to 40%. But it requires you to design the building differently. And we have seen some proof of concepts or building that were implemented in the region using radiant cooling that demonstrated that. So this is one of the things that are my
So for
favorite.
people that don't know what radiant cooling is like, can you describe a little bit how that works?
So basically, instead of having your conventional systems with where you have vents blowing air into the room or building, you have water flowing either underground or through the ceiling or
Yeah.
walls, and basically pumping chilled water from
Okay.
a system that can provide that.
Yeah.
But you have to be careful. There are challenges, especially in this region, with condensations and other things. So
Yeah.
another one is geothermal, which is basically, anytime you dig deep underground, 9 to 12 meters or deeper, the temperature is going to be constant, anywhere in the world, regardless. So because you have this thick layer of insulation,
Yeah.
so you can run, your liquid or water underground to cool it and bring it back, and this helps energy efficiency. And we can make equipment 2 to 3 times more energy efficient than conventional equipment. But again, this region is again unique because you only need cooling in this region.
Yeah.
You don't need heating.
No.
So when you're pumping hot liquid underground, it's going to be hard to diffuse it if you continue to pump it.
Yeah.
Unlike Europe, they use heat pumps. So in the winter, it's the reverse cycle.
Yeah.
So here you may need more boreholes or loops underground in other areas of the world. So some people are exploring these ideas. I think there are a lot of opportunities. Thermal storage,
Yeah.
is another thing where you can run your equipment at night when the temperature is 10 to 15 degrees lower.
Yeah.
And store the energy underground and use it in the daytime when it's very hot, so you can consume less power this way.
Do you see that the GCC countries as such all are sort of like moving at the same pace, looking at these innovations, standards, or are there clear front runners in it?
I mean, one of the key things that I can maybe differentiate countries by here is their commitment to the net zero by 2050.
Yeah.
UAE, for example, they have established 2050 as their net zero target for greenhouse gas emission.
Yeah.
Saudi Arabia 2060. Other developed countries are 2070s. So this will basically, to me, will help expedite where the countries need to start looking at using more energy efficient technologies, concepts, and also regulations to reach there. Because not only you need to basically clean your grid, but also you need to have very high energy efficient equipment and buildings.
Yeah.
Buildings are key. I always say that buildings and equipments are like a refrigerator in your house. If you keep the door open, the compressor will continue to run and you'll continue to consume energy. But if you close the door, the compressor runs very little. So your refrigerator at home doesn't consume much because the insulation is great. The building is the same way. If you have good insulation and good equipment with high efficiency, you're going to use a minimum amount of power.
So that puts us actually it's an opportunity, but also a great challenge, because we obviously have existing inventory that is there, and some buildings are 25, 30 years old. The building envelope is maybe not necessarily as insulated as we would want it to be. So we have a double challenge, right? On one hand, we are creating new inventory, but we also have to retrofit basically what we have.
That's a great point. Actually, I think, I'm not sure 100% on the percentage, but I think 80% of the buildings, 80 to 90% of the buildings that will be here at 2050 are already built.
Yeah.
So you're correct. For example, the UAE in their national determined contribution to the Party of the People in the UN is they have committed to do certain amount of retrofitting in the market. And they're also looking now at building energy efficiency. So for example, in France and England, they have established building efficiency metrics or MAPs. So if your building efficiency is below, for example, a kW or above kW per square meter, you cannot rent it or sell it. This region is looking at things like this, to where now we're going to start reporting on building efficiencies, and we're going to collect data, and then the governments are going to start saying, I'm going to establish, this space based on the data that I've collected, a baseline, and then start raising energy efficiency of buildings as well.
Yeah. So basically, you get a label at the end of the day,
yeah.
And that makes a lot of sense. I think. Do you believe that there is enough emphasis on maintenance of HVAC equipment in this entire cycle? And if not, what are the areas where we dramatically have to change up our game, so to speak?
Yeah, as I mentioned earlier, this is one of the weakest areas or the weakest link, maintenance. And I believe that one of the reasons that it's weak is because it has to do with HVAC technicians. And some of the way that the facility managements are ran. In this region, HVAC technicians, they don't have to be certified. You could be working in a dry clean and the next day become an HVAC technician. There's no training whatsoever. Opposite to what's to the regulations, for example, in Europe or the US, if you're an HVAC technician, you have to be certified, because a technician can affect energy efficiency, he can affect safety, environment, because he's handling refrigerants, and longevity of equipment is key, because if you're buying an equipment, you're spending big capital up front. You want the equipment to last longer. So if it's not properly maintained by proper technicians and facility managers, it's not going to last as long. It's going to consume more power, and it's going to cause safety issues and environment. It's going to have ramifications on the environment.
So what is then the biggest advice to facility management teams, let's say market, because it is not just, it's in-house teams, it is teams that are being hired from third parties to do certain things. Training? Is that the answer?
Training, and also I would say that a lot of them, they claim that they are sustainable. I think sustainability is not a slogan. It should be a discipline to consider long-term effect of every action that they take on daily basis. And starting from self-education, because we're all world citizens. We're affecting our planet. So we have responsibility to be self-train ourselves, and also train, and corporation have to train their technicians, employees, because you cannot take it for a lot of times we take it for granted that especially us in the industry, that this is common knowledge. It's not. Even the simplest things, that tweaking something in the system or monitoring certain things and making slight things that can help you a great deal. This is not very well known in the industry. The facility manager's main concern usually is the uptime of equipment. So they need to shift or add to that, what I mentioned.
Yeah, and I think you're absolutely right. Typically, if maintenance is being executed, we're already happy if the task is done and closed, basically tick in the box. But I think collecting some data before and after, for example, a cleaning exercise, will go a great deal in the right direction, because you start actually understanding what your impact is with the action that you take.
Absolutely.
Which not necessarily is readily available. At the end of the day, a BMS or a CAFM system will not necessarily give you the opportunity to do just that, but you need to connect these dots, in my opinion. When you look at sustainability in the wider HVAC industry from a manufacturing perspective, what is the most important element to focus on for them in the context of our region? Is it just the energy efficiency, or is it also other elements like, for example, refrigerants, etc., that we are using during operations?
Yeah, I mean, sustainability is, I would say, delivering the performance that the manufacturer has claimed continuously.
Yeah.
Manufacturers should not just, or deliver an equipment that can deliver certain performance and then assume that it's going to continue to deliver the same performance when it's installed. It should be sustainability is for the equipment to perform at the same level continuously.
Yeah.
So they need to also be plugged in with their service maintenance and these facilities to educate them on how to keep it performing as intended because once you install an equipment, especially in this region, from day one the performance, the capacity and efficiency start deteriorating from day one.
Yeah.
I mean, and this is unfortunately continues to deteriorate. I've seen equipment after a few years that have dropped performance by 30-40% because of poor maintenance and service.
Yeah. So what does the future look like for the region from an HVAC perspective, knowing that the growth is going to be somewhere around 3x, whatever it will be? It's big, at least. What do you think?
I think this is very exciting for our members. There's going to be a lot of business opportunities and also competition. There's a lot of brands trying to take a piece of the pie here in this region. So I think the winners will be the ones that have the highest energy efficiency product and that can deliver honest products that are tested by third party and certified and proven.
Yeah.
I mean, again, I hope that having to install this huge number of equipments in the next 20 to 30 years is not going to raise our power consumptions because this is not going to help us reach the carbon emission targets that we have for these countries here.
Can the rest of the world learn something from the region here?
Yeah, absolutely. I mean, one thing is that if a unit can run in this region, it can run anywhere else in the world. So the units that are designed for this region usually are very rugged.
Yeah.
And designed to stand the worst elements, not just from heat, but also sand, humidity, corrosion.
Yeah.
I mean, it's a good ground for testing, equipments here. And I think the world can learn that, with global warming, heat's is already spreading to Europe and other areas where it used to be considered mild.
Yeah.
So they need to be prepared that, cooling is not going to be maybe a luxury that you can have.
No.
It's going to be a necessity.
Survival.
And here it's survival. You're correct. 100% correct.
Yeah. What does it mean for you to have a green mind?
A green mind, like I said about sustainability, a green mind is not just a slogan. It should be a discipline that to consider long-term effects or ramifications of every action that you make today. So this is to me a green mind. You have to continuously be conscious of what you're doing and understand how it affects carbon emission, environment, etc.
Nabil, thank you very much for this conversation.
It was my pleasure. Thank you for having me.
Don't miss the next big conversation about sustainability. Hit subscribe.